Hello, everyone. My name is Govind. I represent GlobalSign, and I'm working with this company as a senior sales engineer. Today, we will be talking about three practical tips for the online identities. We will be talking about some real life examples, some use cases as we go along, and this is how we'll progress today. So this is the agenda that we will discuss today. We will first spend a couple of quick minutes trying to understand why do we need strong identities. Then we will have three tips. This is a quick overview. We will basically talk about the need for strong identities. Why do we need strong identities beyond username and password? Tip number two will be to, once you have these identities, how do you use these identities so that you can get most of it? For example, you can use them to sign and even encrypt your data. We will take one specific use case over here is emails. And then last, we will talk about once you have these identities, how do you actually manage these identities for a better access control? So this is what we're going to talk about today. The organization that I'm representing, GlobalSign, is a publicly trusted certifying authority. We are one of the oldest publicly trusted certifying authorities in the world. What you see now on the screen, it says identity for everything, is basically means that this is our future vision. What we're trying to say is that we will be going into the area of IoT and the IOEs, identity of everything, and so provide identities for various different devices that can possibly connect, that can go online, and that can even store some sort of identity forms. That is where we are going towards. So we are saying that we will be in this area to help provide various different types of identities. These identities can be used for various different use cases, and we can even do identity management for a massive number of devices and identities that will be issued. So this is the vision that we have. The next one talks about the problems we solve. So to introduce GlobalSign to those of you who don't know the company already, instead of talking about how old the company is, what products do we have, how many customers do we have, stuff like that, a better way is to talk about the problems that we solve. So over here, you see some of the problems that we solve on the left-hand side. The first one says to reduce the cost and times to deploy enterprise PKI. So what does it basically mean? When we deploy internal identity systems, most widely used, most widely deployed is certificate-based. We, as a company, have solutions and products, both online, both on-premise and cloud solutions, which can help reduce the time to deploy these solutions. On the right-hand side, you see there's a diagram which talks about this. On the top, you see it says on-premise identity services, and then you even have something which says cloud identity service. We do both. Second one says to manage high volumes of identities. It basically means that we can help issue and then manage large number of identities for IoT and the IoE kind of use cases. And then the third is very, very important one, to manage the risks that are related with certificates. So certificates is one form of authentication, as we will discuss as we go forward, but then there are a lot of risks associated when you issue a certificate and when you use a certificate on a day-to-day basis. The last and not the least is very, very important. We help to reduce the time to deploy IAM solutions from months to weeks. Now, this particular line or this particular bullet point talks about two important aspects. One is that we have a complete suite of IAM portfolio. We are quite unique in the sense that we are the only certifying authority today who has a complete set of IAM solutions. And we are the only IAM company who has got a complete suite of PKI services or certifying authority services. So which makes us pretty unique, and it brings in sort of one-stop shop concept where we not only help you issue large number of identities, we can even help you manage those identities on different endpoints and different applications. That's the uniqueness that we bring in. Okay, so the next one is, this slide basically talks about a big at a higher level, the ecosystem that we have, the identity ecosystem. Now, you see a lot of components over here. In the middle, you have cloud, and then there are various different components within it. It says the web services on the lower side. It says consumer web portal, and then on the right-hand side, it says admin portal, and on the upper side of the cloud, it says data web services, partner web portals, and then, of course, on the outside of the big cloud, you have a small cloud that says third-party applications. So these are different services, and there are different components, different entities rather, which connect to these. You have the things, as we call the things, the Internet of Things. There's so many things which are connecting. Here we are trying to show you can technically and potentially put a certificate on a bulb, on a light bulb. That's what it is. These things connect to the web services. You have consumers who connect to the consumer web portal. You have business users and administrators who connect to your internal applications. On the top, you see vendor. I mean, of course, vendor could be some sort of business partners that you have, but it could be anyone else who are connecting to different web services. Now, in all these interactions in online communications, you need different types of identities. Now, on the upper right-hand side, you see there's a legend which talks about different types of identities. The green lock here means you need public trust. So let's say if you're accessing a internet-based website, you need a public trust on the website. So there are two types of trust, two areas where you can have trust. The trust or the identity that is issued to the website, that is one, and the trust or the identities which is issued to the end users. Now, when you are talking about accessing internet-based application, you need a publicly trusted certificate on the website, and you can have a private identity or a self-signed issued certificate to the end user. Of course, there are other areas as well. When we see on the right-hand side, you have the administrators logging in or the employees logging into internal applications like Exchange, AD, Salesforce, which are all your internal applications. Both the entities can have privately issued or self-signed certificates. And then, of course, you have B2B applications where the small cloud talks to the bigger cloud, and then there again you need a public trust because these are again coming from internet, and you don't really trust. There's no inherent trust because this is not a closed network. And on the upper left-hand side, you see it says identity service. That's where we come in. So in this whole complex web, you need various different types of identities. And that's what we does as an organization. We help you issue these identities, both public and private trust, and we can help manage them all along the life cycle of the certificate. Okay, so we come straight to the tip number one. So tip number one says, do not rely on passwords. You need to have strong identities, and this particular concept has been spoken about in the last many years, many times. Most of you would have heard. It says, don't rely on passwords, have some strong form of identities, some strong form of authentication. That's what we're trying to basically repeat over here. So this says, this information here says that you need to, there are a lot of users who write down their passwords. Some 21% write down their passwords. 23% of the users share their passwords. And then 50% of the users basically use the same password for their personal and work-related applications and exercise and activities, which is definitely a bad idea. You should not use passwords, or rather handle the passwords in ways that are mentioned over here. The next one here talks about the costs of weak authentication. So on an average, we say that the cost for authentication breach is quite high. There are various different possible issues that you have as a result of a breach, which could be customer turnover, could be impacted. You can have a reputation damage. It could be legal fee, consulting fee, so many of these things. So average cost comes out to around 2 million GBP for, this is the average cost of a breach. So the next one we talk about is certificate-based authentication. It basically means that instead of using a username and password, you could have a strong form of authentication, which is certificates. And it can help you achieve all that you can do with the password, but then you have a strong authentication. Some examples. Let's talk about some examples. So there are certain examples we would like to focus on them. Of course, there are many more, but we have taken just few where certificates are normally used. And these are the most commonly used cloud applications. You can obviously have non-cloud applications as well. You can have your internal applications which are not on cloud. So you have Google Apps, you have Amazon, you have Salesforce, you have SharePoint. All of these are applications which support certificate-based authentication out of the box. GlobalSign as an organization can help you issue these different forms of certificates or different forms of identities. If you need, if your website is running with, let's say, Amazon, you need to have a publicly trusted certificate for the website, but the users who are logging in, they can have a private a self-signed certificate, and we can help you issue both of them and help manage both of them. So some points over here say that the employees can log on to these applications with digital certificate. It's a strong form of authentication. You don't need a hardware. There are no additional overheads when you have a certificate-based authentication, because certificates are supported by most of the browsers, most of the operating systems. They're supported natively. That's an advantage that you have when you're using a certificate-based authentication for any of these apps. Coming straight to tip number 2, when you have a digital certificate, you can use it for authentication. That is what we discussed. You can also use this particular certificate to do more things beyond authentication. One of them could be to sign, and then another one could be to encrypt your data. So there are various different forms of applications or data communication which can be secured using certificates. We are talking about emails because it's a very common use case. Every single one of us uses emails. There is some research which says about 80% of the corporate data is exchanged using email. So there's various form factors, various areas where we are using emails. That's why we're talking about emails, but you can do many more things beyond emails. Okay, so some of the stats. There is some research which says that 53% of the employees receive and send unencrypted emails. 22% of the companies experience data loss through email each year. 300% increase in the phishing emails. The last stat is very, very important. We are seeing a very large number of customers coming to us and talking about which particular talk about what kind of attacks are happening and what kind of phishing attacks they are seeing in their environment and how they can prevent. So phishing is something which is very, very common. I'm talking about email related phishing. I'm not talking about any online or a banking kind of phishing attack. This is a phishing attack happening over an email. Finance guy receives an email supposedly from the CTO or CXO or someone like that saying that please make a wire transfer, and those kind of phishing attacks are happening very, very common. Just last week I was with a real estate company which manages a lot of properties across the world, some really high profile tenants they manage, and they hold those tenants' personal information as a part of their contract. And the attackers try to extract that information. They try to breach the system and get the information, and then very easy ways to impersonate someone's email address and send a fake email. Okay, so over here, what you see is the simple use case for a user having his email, and then you digitally sign. So you have a digital certificate applied to email client, and what you get is a digitally signed mail. And on the right hand side, you see it shows a red ribbon. That basically means the email has been digitally signed, and when you click on that ribbon, what you see next is a bit of detail that says who signed the email and stuff like that. So here you say signed by Julie Tillett, which basically means the email has been signed by her. Now over here, a lot of people have a notion that it only proves, what I'm trying to say is digitally signing an email only proves the identity of the user who actually signed it. Now, the origin of the message, where it originated, or from which machine it is coming from, all those kind of things are not really captured in a digital signature. It's just that who is the user who has signed the email. that you know for sure. So if it's supposedly an email is coming to a finance team from the CIO, let's say, they know for a fact that the CIO has signed it. Now, he may not be sitting in the office, he may be sitting anywhere else, but the finance team knows for a fact that this email has been signed, and it is really an authentic email, which has been signed by whoever it says it is. Okay, now what we have next is to encrypt the email. You basically can do an email encryption. You are adding one more additional layer to the email which you have already signed, and this comes through. You have on the left hand side you have a digital certificate through which you sign obviously your email client, and then on the right hand side you see the recipient's public key. So this basically means that you are signing your email, and then with the recipient's public key you are actually encrypting the email, and that's why you have a blue lock. And then of course the email goes to the recipient, he clicks on that, he opens the email, and then he can read the confidential email. Okay, so this was about email signing and email encryption. Okay, now if anyone of you thinking that how easy it is to actually launch a phishing attack, and how actually simplistic it is to do this, to impersonate someone and send an email on behalf of someone, I have some screenshots over here, which I did. Basically, this is an SMTP server that any one of you can host, and it's called Quick SMTP or QK SMTP if you see. If the font is big enough on the upper left-hand side, and you can Google it, you can download it, and you can run your own SMTP server. You can configure as many domains as you want. You can configure as many email accounts as you want. Now, I did this a few years ago, and in the interest of the time, I just have some screenshots, not really setting up the whole thing to show you here, but you can pretty much do it on your own. So over here, when you install the SMTP server, you go to the settings, step number 1. You go to domain settings, and then you click on add, and then you create your own domain. So over here, what you see, it says Microsoft.com. Now, Microsoft.com is not a domain, it's not an organization that I'm working with. I'm just doing it because I want to create a domain which I don't really belong to. That's the intent of the attack. Now, then you go to the tab which says users. You click on add, and then you create a user. And I have created a user called Govind at Microsoft.com. Now, I don't belong to Microsoft. I've never worked for them, but still I can create an email address which says Govind at Microsoft.com. So now I have a domain and I have an account with Microsoft.com. Then I use, this is all I did on the SMTP server. Now I move to my actual email client, which is Outlook Express. I used it many years ago. This is not recent. I'm repeating this. I did almost 8 years ago. So back then, Outlook Express was quite a known email client. Now over here, I add a particular user. I say I want to compose an email. I click on add and then on email. And then it shows me, since I have multiple accounts, it asks me which account do you want to use. And I say I want to use Govind at Microsoft.com. Now, I have many more accounts. I have, if you can see the font, I'm not really sure how big the font is on your screen, but I have many accounts over here. It says Govind at Microsoft, at IBM, at HP, at TCS, and so on and so forth. And I've never worked for any of these organizations. Still, I can have an email account with any of these organizations. And now I will be sending emails from these accounts. So the moment I compose an email, and I'll show you in a bit what that email was, and then I click on send, you see a lot of activity running on the Quick SMTP server. It basically shows you the email was composed and it's being sent, and these are different logs that you see in the log status in the console. This is the last screenshot. Now here, what you see is there are two emails basically. On the lower side, you see that's a fake email, which I created from a fake email account called Govind at Microsoft.com. And then I send it to one of my colleagues or ex-colleagues back then. And I'm saying, can you please send this back to me at my actual email? So back then, I used to work for a company called Transition Systems, and the email address, my genuine email address was Govind at Transition-Asia. Now, my friend sends me that email to my actual email address, which is on the top So the email on the top is a genuine email, which is composed and sent from a genuine email address to a genuine email address. But the one which is below is actually a fake email. Now, there's no way that you can figure out between just looking at both the emails that which one of them was sent from a genuine email ID and which one of them was sent from a fake email ID. So that is what email phishing is, and that is what any one of you can do. You can impersonate anyone's email address, and now with modern tools available, you can even conceal the reply to address. So what you basically do is you try to act as a CIO of a company and send a mail to the finance saying that please do a wire transfer in this account for so many thousands of dollars or pounds or whatever, and then you can hide the reply to address. So when the finance guy, the victim, is replying to this email, you can conceal a different reply to address, and the mail will come to the hacker. It will not go to the actual the CIO of the company, because the reply to address has been changed. So this is a quick overview how easy it is to launch a phishing attack, and as pretty much any one of you can do this. So that highlights the importance of digital signatures. Why do we need to sign and encrypt confidential emails? Okay, so we come straight to tip number 3. The first tip was about having digital identities, certificate-based identities. Why do you need? That was the focus. The second tip was that you can use a digital certificate for many more use cases beyond authentication. You can use it for signing and encrypting. And when you have these identities, how do you manage those identities? How do you have effective access control? This is what this third tip talks about. So we say that the IAM has evolved from employee-centric to customer-centric IAM. So it used to be more flat hierarchy earlier, user, devices, app. Now it's more customer-centric, which is more challenging because customers are not coming in from your trusted machines. They're not coming from trusted devices. You don't know what form of, where they are, from which device they're coming on. So it's really, really complex when you go outside your employees. That's what's called customer-centric IAM. That's where GlobalSign is an organization. We specialize a lot in that area. Okay, so what he's saying is you need to have a centralized identity management. We break down the silos of identity management, which you typically have if you don't have a solution like this, and you have a centralized, unified identity repository. One use case that you can think about for where you can use this kind of identity management solution is CRM integrations, customer relationship management suites. There are a lot of solutions out there, and it's quite challenging to manage these users in a CRM kind of environment. Again, CRM is just one use case. You can have many more use cases beyond CRM integration. So we are again giving you, this is again a use case. I'm showing you a screenshot how the solution can be used to manage your contracts. Let's say we're doing some sort of contract management. Now, what you can do over here is you have an option to add a particular user in the middle side. If you can see, it says receive service contracts. You click on the button which says add role for users, and then you can add the user's company ID, his email address, and the roles that you want him to be: a visitor or a member or a super admin or whoever he may be. So this is how you can onboard the user. There could be a manual way of doing it. We could possibly build in some workflows and approvals which will be in place, and that's how you have a user onboarded. So once the user is onboarded, he has a role-based access. You can manage his identity on one application, second application, let's say Salesforce. Then you can have something on Amazon. You can have his identity manager on Google Apps, and so on and so forth. The next piece in IAM, again, which is very, very important, is single sign-on. Once you have the identities established and created, then you need to have some sort of single sign-on if you have multiple applications to log on. Now, We have a solution, and one very important point, good point about the solution that we have, that it supports various different forms of authentications. We support some 20 plus authentication methods today, and a few more will be added. So that gives you a huge benefit. You don't have to really rely upon just one or two or three or four types of authentications. We can support many of them, and certificate-based authentication is one of that. On the lower side, you see there's a flow. There's a user on the left-hand side. He has single sign-on. Then there's an authentication layer. Various different authentication mechanisms that we support are over here. And then you have the actual access control depending upon his role, which web portals, which websites he's supposed to access, which he is not supposed to access. All that is factored herein. And then there comes the real authorization. This user is authorized to access intranet, extranet, web services, cloud applications, stuff like that. So we are basically giving you a complete range of IAM solutions, from identity management to single sign-on. And there are a couple of more things which I didn't touch upon here in the interest of the time, but it's a complete range of IAM portfolio that we're giving you, starting from the certificates to issuance of those certificates, management of those certificates, not only managing them within one application, but different applications. So this is the whole range of PKI and IAM services that GlobalSign offers. So that brings me to the end of my session. I think we have time for pick up a couple of questions. Give me a quick moment. One question we have says, does GlobalSign support soft PKI smart cards? It's a good question. So we, at the moment, we do not have a support for soft PKI smart cards. There are some discussions going on at the moment. Honestly, we cannot even talk about roadmap, but yes, there is some discussion going on, and we do have a lot of need coming up. A lot of customers ask whether you support smart cards out of the box. We do support hardware smart cards, by the way, but not software smart cards at the moment. The only form factor of smart card, the software smart cards we do today, is standard PFX and P12 file, which most of the applications and browsers understand. But then there is a security risk in just relying and depending upon those kinds of native smart cards, because they don't really provide you with any sort of anti-skimming or anti-phishing, anti-farming capabilities. They can be skimmed and cloned easily. We realize that the only alternate we are providing today is hardware smart card, which is time consuming to integrate and deploy, and then of course the implementation timeframes are quite high. So this is how I would like to answer. When we have a roadmap available for that, we would like to get back to you, maybe make some sort of an announcement on that. But at the moment, we don't support software smart cards out of the box. We only support hardware tokens. So that is one question we have. We have still a minute to go before the session ends, and we can wait to see if we have any more questions coming in. Is whether we have APIs to help issue these certificates to customers who need it. They don't want a manual issuance; they want a sort of an automated issuance. Yes, so we do support APIs as well. We have different types of APIs for different types of certificates and different hierarchies. And yes, you can issue certificates through APIs, which will be completely automated. And you would not require any manual intervention, which is typically required when you have a large number of certificate issuance. And also we can do revocation. We can do the certificate management through APIs. It's not just the issuance, it's the revocation and the reissuance as well, which we can do through APIs. So yeah, we do all those kind of things. And depending upon what kind of use case you have, we will help you with respective APIs. If you need more details, you can get back to us sending an email to our sales with email address on our website. We can get back to you with the respective details, and we'll take it from there. So I think we are just a few seconds left from the end of time. So thank you guys for taking our time and attending this webinar. Hope that it was helpful and informative, and talk to you soon. Bye-bye.